Hello and welcome to April's Systems Facing CARC call. My name is Dory Sidock and I'm a system administrator at the University at Buffalo Center for Computational Research. With me today, we have Brian Haymore from the University of Utah, who's helping me co-host. And our plan for today was to have an open conversation about some of the challenges we've all been facing related to supply chain issues, procuring equipment. This started, years ago when the pandemic first locked us all down, but it's continuing on to this day. And some of those issues are just residual supply chain issues, but then I think some of us are also seeing that there are certain types of components that are getting harder to purchase just because the demand for them is so high. For example, GPUs. So we wanted to bring this community together, talk about some of those challenges, and maybe you have ideas on how you've worked around them, or we can share, some strategies going forward. We could probably spend all day telling tales about the stuff we've been through over the last 4 years. And that might save us some money in therapy, but it's probably not really going to help us out. So we did put together a few slides to hit some of the more important topics. And then we also wanted to kind of move forward. We think this might really be our new normal. So what are some of the other things you're looking at down the road? Are you having trouble getting or paying for power, cooling, data center space, things like that? And then, as Brian mentioned, we're going to be using the call doc heavily today. We ask that you kind of fill in some of the answers to those questions so that we can use this document going forward. And then if there are things that we've missed, it would be great to have that in the doc too, and we can certainly talk about those here. So we're going to show the slides, and Brian and I will talk about the types of issues our centers are facing, but we also want you to chime in. So feel free to unmute yourself. You can raise your hand if you want to, but unmute yourself and just share what you've been facing or ask questions as you feel you'd like to.
I could throw something out here too. With the fact that we have the tables with the questions already in the call doc, you can also feel free to go ahead a little bit and see kind of what the following questions are and kind of throw some additional things in advance.
So before we start, before we move to the first slide, Brian, do you want to make your announcement?
Yeah. So just making a plug for, the PERC 24 registration being open. There's a couple opportunities that we really wanted to kind of highlight and focus to this group. One is they're both wrapped around the student program, but one of them is making a plug for mentors for the student program. So if you've already, gone through PERC registration and there's a question that's asked directly in there, whether or not, even if you said, no, you didn't want to be a volunteer, if you're interested in being a volunteer, you can reach out. And in the call doc, I do have the link to the student program email address. But we'd really love to try to get a good set of volunteer mentors to kind of cover the bases from all the different potential interests that the students would have, so we get a good match. And also make the plug for, if you have students that you're associated with, and it's appropriate, please encourage them to look at applying. There's some really great activities and opportunities that the program will give them. And the due date for that application is May 15th. So again, feel free to reach out to the student program email list, or you can poke me as well for any additional questions on this. That's it, Dory, back to you.
Okay, so our first kind of topic of conversation is what components are you having trouble getting when you order them, within a reasonable time frame, 2 or 3 months at maximum. These are some examples of things that we've had a problem with getting recently. Some types of GPUs, we currently have an RFQ out right now, and there are certain GPU types that have lead times over a year, but then others we're able to get quicker. There are some vendors that we deal with on network switches. Some of their network switches have enormously long lead times. In the past, we've had problems getting InfiniBand cables. We, of course, have chosen a specific type of rack and a specific model of rack that we really like. And of course, that one is always hard to get. PDUs had been a problem previously, but those seem to be kind of be a little bit easier to get now, but that also might depend on what type of PDU you use. And then we also had a pretty big issue getting replacement batteries for our UPS. They took, I believe, 8 months to get all the batteries on the floor in order to replace them for our like center-wide UPS. So those are just some examples, but Brian, I think you probably have some others.
Yeah, I mean, your list is overlapping heavily with what we're running into. There's some extra things more about some data center plans that we have. We have an added dry chiller that we wanted to add to the loop that is proving to be quite challenging to get. There was a little bit of getting the right, it was harder to find the right engineers to come in to kind of spec out the plan. And then once that was done, it was a heavier lead time. So I think we're still about 9 months out before we'll get our cooler, in hand and in place. So, and we're starting a phase of planning for a data center expansion, and everybody is telling us to be planning for these same types of things. That parts availability as well as the people skills are harder to line up.
Does anybody
Covers.
else want to
Yep.
chime in here? Any other things that you're finding that are difficult to get on the floor?
And here we'll make the plug, in the call doc, we have the section. I see that we've got some additional people adding in answers on this first one. Happy to have you type it in there if you want, message us in the chat too. Some of you may not be in a situation where you can unmute.
Brian, do you want to read any of those?
Well, it's like the first additional one is listing GPUs as well. Some types like you were mentioning, we've got InfiniBand switches, cables, the models of vendor network switches. The next one is talking about InfiniBand switches as well, GPUs. They're seeing some 8+ month lead times on some of the GPUs. Some power users want specific equipment. And actually that last little point there is, I think, a key thing I would love to see some contrast on, because we operate our resources very much in a condo model, and there is a lot of opportunity for the individual PIs to emphasize some individual parts, like which GPUs they want or some of the particular storage aspects they want for some of the resources they put in. And so that leaves us not able to completely predict what the next purchase will have. So I am curious if others who are buying in large chunks are seeing a different result, versus others who are buying kind of in smaller units that would fit more of a traditional condo model. There's a comment in chat about the data center space, and I think that's a valid one too. But for me, at least, is what I think we were alluding to with any comment that University of Utah is starting to look into how to expand the data center, what the costs will be. Those costs are coming in the early estimates to be much higher than we would have hoped for.
So
Hey, Brian, when you originally built it, did you built in possible additions to the data center?
Yeah, so our data center has about 75,000 potential square feet of space. Only about a third of that was actually finished in that initial retrofit. So there's another third that was queued up with the plumbing for things was already in place, the concrete pads out in the yards for the dry coolers, the evaporative coolers, pump houses sized for the additions, and the electrical, connections are all kind of precise for this. So there's a lot of it that we did up front to try to be ready for the next expansion versus it being like, fresh from scratch build. But in that, a lot has changed, in the sense of these parts and availability, pricings, but also we're potentially going in and asking for a liquid can fit into this that we didn't do last time. So there's some complexity we're bringing, but there's costs associated with that. But we're just barely getting started. We're really nervous about what we're seeing from the pricing and availabilities, but we're not very far into this process yet to really say how it actually is going to turn out.
Yeah,
Mark just
sorry, go ahead.
Mark noted handle the transition from 20 amp to 40 amp PDUs in the cabinets.
Yeah, so our data center, let's see, we moved in there, I think 15 years ago, and it was 2 to 3 times the size that we needed at the time. It was built for a different type of compute use. So we've never come close to filling that. And with the way the servers and the power, the servers were becoming more power, let's see, they were using less power, right? And we could condense and put more into a rack. So the space was fine. The problem is now we're looking at bringing in these newer GPU units that are data hogs. We don't have the power capacity to support that size of a data center, and we have cooling issues. So even though we've got all the space in the world, it's not going to help us out when we're looking to expand the actual compute capacity of our center. Okay, so let's move on to kind of, this is probably going to be a little bit more useful to us. Actually, sorry, that's the next slide. What are the types of impacts that you're seeing due to these delays? For us, we've had a few issues where we haven't been able to meet the project requirements. The researchers get grant funding. They need specific equipment that either they can't get now or it's just it's delayed. And then those payments can't be made on the purchase until the equipment arrives. And now we've gone past the funding deadline, so the funding can't be used. So we've had a few issues like that, or their grant reports are due and they don't have the equipment on the floor, so they haven't been able to do anything. And then we've also had some issues where we have a large purchase, lots of different components, but it's one single part of that purchase that's being held up. And so the order wasn't processed. So we are trying to be really careful with that going forward to make sure that whatever we order can be filled and on the floor altogether, so that we don't face these deadline issues anymore. And then another thing, we had talked to some vendors about possibly breaking up an order. Let's say you can't get the InfiniBand part of the order, you either can't get the switches or the cables or the cards. Let's separate that out from the large order and just order the compute separate. But then what happens with that is some vendors aren't able to split that apart, or the discount that they were initially going to give us isn't going to cross over if you split up the order. So there's some kind of just logistical issues like that we've noticed.
I'm going to add in that we've run into some of the similars. A lot of this really got started for us during the pandemic, kind of limited resources kind of era, but finding vendors unable to ship a set of machines where it's one part, and it's not even a critical part from our use case, that is delayed, and they can't send it to us without all the parts. And they can't extract that part after we've placed the order. So during those times, we were kind of, from a couple of vendors, being told that our option was to wait or to cancel the order, lose our place in the queue of orders, and have them requote and then repurchase. But then when we requoted, just like Dory was saying, the pricing on that part we extracted out is not given the same discount because it's not seen as part of the larger purchase. And it just kind of showed that the companies weren't all as well prepared for this. There was a lot of just their processes that didn't lend well to this. But we also found a couple of the groups that would ship a partial, and then deliver the other part later. As well as just learning to ask more questions of the vendors of if it's a power supply, if the one of that size is not available, is one just slightly larger more available, and having them try to help sort through to avoid some of these hassles. So we still see this a little bit, but we've kind of now know which of the vendors who can cope with partial shipments and which ones can't. And I guess we try to have all this figured out before we actually place the order now, more than we knew to do before. Let's see what we've got in the doc on this. We've got one comment here that they primarily having issues with expansion, as plans need to be made more flexible in order to adapt to, the lag of networking GPUs, etc. What other things are we not hitting on here that people are seeing as far as impacts?
I'll just tell a story while people are thinking of that. Last year we placed an order, a large order with a major vendor, and they also let us know if any of our faculty wanted to purchase servers at the same time, they could extend the discount to those orders. So we had a bunch, we have our primary compute cluster, but we also have a condo cluster. And so we had a bunch of faculty order some GPU nodes, and they were maybe two weeks after our order went in that they were putting those orders in, and the vendor had to come back and say, I'm sorry, but we can't fill these anymore because we just got a major order from, I can't remember if it was Facebook or one of the very, very large companies. And so now we're not getting those GPUs anymore, and we're only selling, these other ones. So they had to change their order and go through that whole reversal of purchase order process, and that was kind of annoying for them. But ultimately, they were able to get what worked for their research.
Maybe that makes me want to ask the question, Dory gave a couple examples of, these after the fact impacts, whether it be to the grant funds she couldn't spend or just what she just described there. Maybe you're running into problem with getting vendors to be able to quote things accurately, effectively enough that you could use it in, a grant proposal up front. Or does that still seem to be moving well enough for the grant proposal side of things? It doesn't have to be grant. It could be going after any funds, campus-wise or not. Go ahead.
Brian, I would say in a lot of the grant proposals, you kind of make a guesstimate based on, what numbers you can get out of a vendor. But then when you go back, when you actually get the money, you have to go back and actually get quotes. So I think this doesn't really harm a lot of the procurement or a lot of the proposal process, because you just have to have sort of a ballpark figure when you put in.
I agree with that. I guess more what I was wondering is with these big year-plus lead times that can exist on some of the specialty GPUs, is that causing any issues there? Or do we just get our quote and then hope the vendor can actually deliver on that when we actually have the approval and go to actually solidify, like you're saying? Just curious whether any of the vendors are giving you some pushback on when they can anticipate things.
So in our current RFQ that's out there, we specifically put this equipment that we're purchasing now in April needs to be on the floor by August, because our grant deadline is the end of the year. So we need to make sure that even if they slip on that deadline, we have it in time to install it and test it and pay for it. And then we said, include in your response to this proposal, exactly what your current lead times are on these components. So we got that response from all the vendors, but they were specifically referring to the compute nodes. And so we need to go back and also say, what about the InfiniBand equipment, the cables, all that kind of stuff. But we were at least able to see, you know, like I don't even know why they quoted us like the H100 GPU, because the lead time is like February or March of next year. So obviously that's well beyond our August deadline, but it's possible they just included it because they knew we were looking at those. But at least they were able to give us some decent approximations of those lead times, which is very helpful to us when we're trying to make a decision to purchase. But I think based on our experience with some of these other grant projects where people were buying equipment after they got their funding finally, now, like you said, we're asking more specific questions of the vendors rather than just buying it and hoping it comes. You know, it's forced us to ask those more specific questions. Okay, so this is what I'm most looking forward to, hearing about what solutions or workarounds you have all either already employed or have already considered. I did just talk about how we are specifically stating in our RFQ that we need to have the equipment delivered by a certain day. We can sort of check with vendors and tailor our RFQs to include like what's available now. We didn't end up doing that. We just said, you know, we want a certain number of GPUs, and they're kind of giving us that information, but you could certainly do that. You could get an approximate time from vendors on what their current lead times are. One of the things we had considered was ordering some of the components separately. So for example, this time, normally we would when we order a cluster, we don't order it already racked and installed. We order everything separate and we put it together. But the order itself goes all together. So we have our racks, we have our compute nodes, we have our network switches, and everything just gets ordered in one purchase order. So this time we knew the racks were going to take a while. So we ordered those 2 months before we even put out the RFQ for the cluster. We talked about potentially ordering the GPUs separate, but we ended up not doing that, primarily for the reasons we've already talked about. Discounts are going to be skewed for that. Some of the vendors aren't going to be able to do that. You can't just order a compute node and a GPU separate. We were kind of worried about how that would affect the warranties on the systems and things like that. So these are some of the things we've done, but I'm sure that you all have some other good ideas to share with us.
Kind of two issues related to this that affected us at University of Utah. We got into the habit because of a lot of this to be buying our next, you know, top of rack IB switch and all the cables for the nodes before the nodes are ever even spec'd and ordered. These cables were one of the harder ones. I think that's less of an issue now, but we're pre-buying things where we're not as worried about the warranty or the complexities of things we used to just have come with the node. One of the other things that this is not the whole reason, but it's part of it. We've been looking at alternates to InfiniBand. We're getting ready to deploy a cluster that will be, you know, RDMA over converged Ethernet based for the workloads that we think will work well in that environment. So that's kind of workarounds is not having to address some of the problems that were a bigger issue as we were kind of getting started.
Anybody else have anything to share on that? Or is there anything in the call doc?
there's a comment of others looking at the Rocky, the RDMA over converged Ethernet.
Yep, that's on our to-do list too. We're not going to use that for this current purchase that we're doing right now, but it's on the to-do list for the next one.
This is a side piece to my comment earlier about us trying to get an additional chiller. One of the impacts, that this has caused for us is we are having to retire some of the gear sooner than maybe we would have. We run gear a very long time, so it's not like we haven't got our life out of the gear, but having that limited space is, space that you can cool is the better way to say it, is forcing us to make different choices than I think we normally would have. I think that's going to weigh in as we move forward. So while this is not quite a workaround, it's just more of the observations that we're having to be a lot more thoughtful on what the requirements are, space and heating on things than we've had to do for a while. That's, when you have ample space, it's easy to kind of be a little bit negligent on the micromanagement of your space and power cooling until it becomes an issue, and then you have to learn to quickly get more organized about that.
Yeah, we're in a similar space on that too. We normally will run our systems for 7 years, but we have been extending this out, and I think our oldest equipment that we just shut off recently was 10 years old. Compute nodes I don't want to say how old our current core switch is, because that will jinx us, I'm sure. So it's very old though. And a delay purchasing the new switch. That new switch, now we ordered it, I think, in the middle of the pandemic. That took 14 months to arrive on the floor. So that delayed that massive network switchover project for a really long time. And that caused a lot of other problems with other projects. The last time we made a purchase last year, when we couldn't get our racks, we had all of the compute nodes arriving in boxes and needed to put them somewhere. So we reused old racks, got everything set up, burned in. And then when the new racks came, so exhausting, but we transferred everything over to the new racks. So we're really trying very hard this time to make sure that everything is coming in at the same time, so that we don't have to do silly things like that. Okay, so let's move on to the well, I guess I have a couple of slides here for solutions and workarounds, which I think we probably covered most of these. Although when we were talking about this in our planning meeting, one person suggested if you're not able to purchase the equipment that you need, like let's say GPUs, you just don't have enough for the demand in your center. Are you considering, or are you currently using commercial clouds, leased systems, any of the access? Are you pushing your users to the access systems until you can get your hardware online? We haven't done any of that yet, but I'm curious if anyone else has. Okay. And then just a couple of the other ideas where, if you can buy extra parts, at the time, do that. Make your own cables, those kind of things. When we were having trouble getting the InfiniBand cables, it took us a long time, but we thought, hey, we should start looking to see if there's another place we can get them. We finally found somebody online and we bought a few of those. We've tested those out. Of course, as soon as we got those, the order that we placed 8 months before arrived. So we didn't need to use them, but now at least we know we can get those somewhere else, and those cables work perfectly fine and are a perfectly good replacement for the vendor specific ones. So the other thing we wanted to talk about is just some questions around sustainability. Are you having to make decisions related to the availability of power and cooling in your area? Do you have issues with water availability? Is the electricity very expensive in your area and you're not really sure how to deal with that? We're very lucky in Buffalo because we're very close to Niagara Falls, so our electricity costs are not high. The majority of that power goes to New York City, but it results in us having reasonably cost electricity, and we don't have water issues either. But I know some of you do, and it'd be interesting to hear what types of decisions you're making for the current issues and then what you're thinking about for future.
It's an indirect on this, but some of the things we've been playing with, with this data center, the added cooler, the expansion we're doing, talking about is we've actually struggled a little bit with on the power, trying to convince our larger campus community to invest in the transformers that we could have put down there that we would own instead of the utility power company. Because if we did that, it'd shave some of the costs off the kilowatt hours. And a lot of that comes because you're talking with all these different stakeholders and there's different perspectives. There's groups that see themselves completely going out to the cloud, in the long run. So why put money into something now that they may not be, they may not believe that they're going to see a return on investment. So our electricity is reasonably priced as it is. It could be better, I guess, is one point with an investment. We're in a very dry area, which makes evaporative cooling, solutions wonderful, but we're in a dry area, so there's not that much to evaporate. That seems to be a challenge. And then we run into, like I'm sure some of the other areas that are dry, there are times of the year where that you're not as dry, and so those evaporative coolers are not as effective. And the idea for us to bring in more liquid cooled solutions has us, I think, concerned how to be consistently able to do things. So I would love to hear from others if they've dealt with things along those lines.
I had a question. Have campuses invested in like solar power purchase agreements or anything like that where they, contract for a company to build a solar farm either on land they own or land that's in their power grid in order to get a more sustainable power source? Obviously, like Dory said, that you don't have that problem in Western New York, but we do have it a lot of places. And if you can, there are sunnier places than State College, Pennsylvania within our power grid. So it can make sense to contract with a company that's, building these type of projects inside the grid, the Pennsylvania, Maryland, New Jersey grid, and to deliver power, more sustainable power to the equipment that needs it on campus.
I see in the chat, Jared noted that NCAR is working on some solar. You mind commenting a little more on that, Jared? Is it data center focused energy or?
Yeah. So I guess not sure all the details have been fleshed out, but our data center is in Wyoming. We have some extra land around the facility, and it has more to do with carbon impact on our site rather than price of electricity. But so we're looking about possibly putting some solar cells off to the side of the building that would be used pretty heavily, and the area in question actually gets many days of sunlight, so we're hoping that'll be successful, but I don't think all the details have been completely worked out. It's certainly not going to set all our compute power for the data center by any means, but it'll help.
Yeah, that's interesting because we were also wondering about that. Are there any centers that are specifically looking at any of these issues more for their carbon footprint rather than what it's going to cost. We have a potential, we actually at the University of Buffalo have a solar farm. And the data center that we moved out of on the one campus 15 years ago to move to another campus actually has more power capability than we have currently. But that other campus is browning out every other month due to researchers bringing in GPU servers into their offices. A few smaller data centers are on campus and they're also having issues with GPUs. So there's a statewide initiative that is pending funding for an AI institute, and they want to house that at the University of Buffalo. And so they're currently looking where can we do this? We can't put it in our data center. We don't have the power capability, and trying to add power to that is probably not going to be cost effective. And since the entire university really needs a good data center for everything, I think that they're going to end up building a new data center. And I'm hoping that they look at some of these sustainability issues when they're doing that, so that it's not just like, okay, wait, it doesn't matter what it costs for electricity around here, we'll just build this new data center. I think there's a lot of things that they could potentially do. There's a Yahoo data center near us that uses the ambient air from outside to help with their cooling. And I think that's a great option for Buffalo. It's not always warm here. So we can definitely use those kind of things, and that helps with our carbon footprint as well.
Yeah, I think Jared makes a good point. It's mostly not about cost cutting to do solar. It's mostly is about your carbon footprint or your impact on the environment, because you can get a lot cheaper electricity from natural gas than you can from solar right now. Now that'll change in the next 10 years or so, but it's a fact right now. Well, and certainly where we are.
Right, but I think some of this, this tone of the topic, we can spin around and relate to some things I had seen from some previous presentations, like around what TAC has done, and I'm sure others have done some of these things too, where you're looking at how you're cooling and whether or not you can kind of play the game of costs that might change throughout the day between peak hours and off peak hours. And so it intrigues me whether anybody's kind of exploring this further than what TAC had done previously, or again others who may have already done this, to do this, maybe both because there can be a carbon footprint, but also because we can address some of the costs, even if it's not just all about the solar and electricity gen. It could be how you're cooling things, what time of the day, the big insulated water tank that TAC had for one of the previous generations. I'm not sure if they still currently have this, where they could cool it during the night and then operate on it through most of the day before having to go back and cool it again. Was a pretty interesting idea. I don't know, maybe to kind of twist the question, is anybody else exploring kind of these innovative ways to save money and maybe be less impactful during things due to peak time kind of games on power or other things?
Yes, our site doesn't really have a diurnal variation in the cost of power or availability, right? Our center is HPC specific. That's what we do. It's really the only thing in the building. And a bunch of the work that we did when we built the center, years ago, was concentrate on energy efficiencies and whatnot. So we've been saving as much power, and really we've kind of worked to optimize our PUE in general. So we don't really have a problem with that. Now, that being said, we are monitoring energy usage, and users are getting reports of how much power they use as part of their job completion, so that they understand. So if we do have to go back and say, use this much, and then this was the cost of electricity during this time, it's a simple math equation, right? We have the data that we can go back and and say our users actually use this much monetary value in energy rather than just well, we sucked up this much energy over the month of, March or whatever. Trying to, I guess, put together the pieces of what science costs what in electricity.
It's off topic, but at some point I'd love to hear you walk through how you're doing that with shared node circumstances.
We're ignoring shared nodes mostly on our bigger system, right? We're trying to figure out how to do that, but just the overall monitoring at the node level just isn't quite there yet on certain subsystems, right? So
Yeah.
yeah, it's mostly driving on our big system, the one that cost us a lot of money to power.
Okay.
I guess the other thing that we might consider is if we're going to go water cooling, we're wondering how far we can scale that up instead of doing either just one rack at a time or something. Can we move cooling distribution units into maybe like a building function instead? So we have chillers and the CDU mechanism, and we just run pipes everywhere instead of having a bunch of CDU equipment that is smaller. So we're looking at engineering aspects to do that and what it would take to have bypass systems and other ones so that we can run the system, continuously in an uptime phase. How do we put 2 CDU loops to everything and whatnot? But it's going to be a long project. But as as the chips get bigger, hotter, and no discrepancy on, really providing any thermal capability. I mean, we're already at altitude, and so that makes air cooling challenging as well. So water cooling is kind of becoming just a requirement on some of these newer GPU systems. So, but you get cost of efficiencies when you can really figure out how to scale that up.
I'm not remembering who had said this, but one of our regional meetups that the Rocky Mountain group had done, one of the groups was talking about some of the passive cooling things that they were trying to implement that, if I remember right, could kill some of that liquid loop. And it just took the edge off, right? Because it's a passive. Is that something you're also looking into?
Possibly, but again, altitude affects us probably in more ways than we care to admit. But also just, I don't know, the sheer volume, right? If it was one rack, maybe we'd figure out how to force that. But when we're looking at multiple pods of GPUs, like you just start considering that, well, water water is just better like liquid in general is just a better cooling agent than gases, right? So
Yeah. But what I think I was remembering from whoever it was that shared was that they were essentially running their liquid loop kind of externally through a massive outside heatsink that just was passive. And if I remember right, it just took it down a few degrees, which was still an advantage, even though it didn't solve the problem.
Yeah, I mean, our building loop is got evaporative free air cooling and everything like that. We don't run our chillers hardly at all. Few days in the summer when mandatory, but leveraging that system, I mean, we can kind of break it down into like almost 3 operating modes. We have free air cooling, which we can just basically do a little bit of evaporative. Then we have cooling towers, which we can do forced evaporative in a sense. And then we have chillers that can handle when our summer days spike into the 90, high 90s or whatever. But we try to just run as much of our evaporative as possible. And so we do take in external building air. This is all done with weather studies and everything of the facility and site selection, right? A long time ago. But so yeah, when it's cold up in Wyoming, it's advantageous for us. So
In the chat, Adam mentioned that their chilled water facilities freeze water overnight. and then thought during the day, which I've never heard of, which I think that sounds pretty cool. Years ago, we were able to get some funding from New York State to purchase a separate in-row chiller system. So in between each rack was its own cooler, and that was fed by a separate chilled water loop that was outside of our main chillers in the data center. So that kept the racks individually cooled, which saves, you're not cooling the ambient air in the room. Those lasted a really long time, but unfortunately, with no facilities maintenance or little facilities maintenance on those, eventually components start failing and then the system doesn't work. And I think overall they last about 8 years. And now with the potential of getting one of the bigger NVIDIA GPU systems, they're talking about those have to be water cooled. And so they're looking to see if that chilled water loop might be able to be reused for this. I don't think it's possible, but it's something that I did want to mention, that if you are looking for ways to improve your cooling in your data center, you might look to places like your state or other funding agencies that would help, with they're looking for sustainability and that type of stuff. So they have funding for those types of facilities improvements. Before we end here, is there anything that we missed that anybody wants to share, like that they've thought of or they've had to deal with on any of these topics? I know that people were adding to the call doc, but if anybody wants to pipe up and just, bring up a topic that you think we might have missed, that would be great.
It's for those of you that apply for grants and anything, or your program officers understanding of not being able to get parts, even if there was a quote guarantee in the a delivery, right? Like there's the second side of this, right? Which is, if you're in danger of losing money because you can't get something, are they being understanding that, well, we can't get anything right now? Like you literally just can't buy it or it hasn't been delivered yet. I mean, I'm thinking about like the earthquake that happened, right? And it shut down TSMC for a little bit. That's an unforeseen thing, but it's probably going to have a ripple effect of, a couple weeks for different people. So I'm just quite curious if money expires, how are our funding agencies being more understanding that we gave you money, but of course you can't spend it, so then what was the point of giving the money, like, to some degree?
I think in the case of our, the one larger project that one of our PIs was working on, they were pretty understanding. They gave them, an extension to the deadline. We are not directly involved with the project. We were just setting up the equipment. So we kind of had to push that as a higher priority than everything else once the equipment arrived, because they had been waiting for it for so long, but they were pretty understanding. Some of the funding that we currently have, though, to purchase equipment for our center, they're not going to be understanding of that. Like there's a deadline to use that, and if we don't use it, we lose it. So we're really pressing the vendors to make sure they can get us what we have ordered in a timely fashion.
We've had some similar internal problems with that, where it's use it or lose it funds, or residual funds, right? Oh, we have this much money, you need to be able to spend it in 1 month and it's like, well, can't, like quite literally can't. So it's interesting how I think that needs to change in the landscape overall. Like, have an earmarked thing that says, yes, it's at least on order.
Yeah.
So we're staring that down also. We have an RFP about to go out and it's got a fixed spend deadline, and we're kind of pushing the vendors. Everybody's been talking a lot about getting real timelines from the vendors. And my experience so far, pre-RFP, talking to our vendors, is if you press on them at all, they'll say none of these numbers are real and they can't guarantee anything. NVIDIA will say 6 months, but what that means is if I stare at the thing right now, the orders that are in the thing and the queue time on the fabs, 6 months is the earliest I can make a GPU I haven't already sold, best case. But the reality is that, right, if Meta jumps in with another $10 billion to buy all the B200s, they don't care about they don't care about me. So when you push in on them some, I can't even go to somebody and say, well, I've got all these timelines. So if we put all these timelines together and line these things up, here's the grid, here's the timeline of history. I can spend this money by X because they promise for sure I can get all these things. And it doesn't really seem to matter which vendor I'm talking to. They all say essentially the same thing. Like once they start getting out past 6 months is sort of the number I have in my head. They're guessing is a strong word for it, but a guarantee at 6 months is not much of a guarantee unless maybe you're spending at a certain scale. They'll guarantee you things, but my institution at least is not, generally speaking, spending at Facebook scale. So we're having a lot of kind of questions about how do you deal with, say, like a mixed cluster, which is what we normally buy, a mixed CPU and GPU for capability type stuff. Should we be doing 2 RFPs so we can at least buy half of it? Should we talked before we had some dust ups with an RFP that we had to cancel and reopen, and before that RFP we talked about, should we order just blanket order from a state approved vendor, just order the InfiniBand switches right now? Who cares? The pricing on those things is such a small percentage of a $5 million cluster order. Who needs the discount? That's not really the problem. The problem is all of this other stuff. Let's take anything that we're comfortable putting into a rack, that we're comfortable plugging into a computer, and just buy it and just put it in a pile in the corner, because even if it's sitting there burning its warranty off, it's sitting there. It's guaranteed to be there when the rest of the stuff shows up. And, we had a lot of issues kind of pushing back into our sort of, I don't know what the right way to say it is, the funding leadership, the flywheel of figuring out who can spend money when, is to say, well, I need to get an allocation out of the allocation that you've already established that we can spend early so I can buy some of this stuff that I'm concerned about will stop the cluster. If I can't get the InfiniBand cards or the InfiniBand switches or InfiniBand cables, which was, like you were talking about earlier, one of the funnier ones, which is like it's a cable. You don't even think about how hard it's going to be to get a cable. Then they could deliver the whole thing and I can't finish acceptance testing, which means I can't pay them. So they could deliver the whole cluster and then we would just be staring at it and maybe have to send it back because timeline pushes past funding spend, funding disappears. I just have to say I can't do the testing because the cluster's not finished. Now, where are we? The vendor's in a bad spot. We're in a bad spot. They're not going to want to bid for us again. We're just dealing with a cascade of issues around these sort of static funding models. And it's just been throwing around a little bit with the rest of our team, which is what are the alternatives? What can we even do? Because you almost need essentially a loaded money gun ready to point at anything you can buy when you can buy it, so you can buy it and put it in a corner. Because having a pile of GPUs I could put into a computer right now would be the most valuable thing I've ever spent money on. But how did I know that 2 years ago or 3 years ago, when it would have been clever to put a pile of even PCI Express card, it doesn't matter, right? Anything would be valuable for my researchers at this point, because we just need more capacity. They just want more GPUs. Even slow GPU is better than no GPU, right? It's just so difficult to put those pieces together with timed funding when these supply chains don't exist practically. I mean, you were talking about H100s. We've been having that conversation with NVIDIA also, and we're getting into a point where the lead time and the generational shift times are crossing over to such a degree that even if I put B200s on a thing right now, there might be insert next letter 200s out by the time those would even be possible to get on their timelines. And we have to deal with like sort of the real, what do I call it, the fab capacity concern of, are they just going to stop making B200s by the time they would ship that, because it's more profitable for them to take that fab time and make insert new letter 200s here? So production just dies. The promise that they had is like, yeah, but we stopped making those. So sorry.
Yeah.
What do you do about that, right?
Yeah, we feel under the gun and we don't exactly have an idea of what we're going to do, but like our A100 partition, right? it is supposed to have a warranty for another 4-ish years.
Yeah.
Well, it's already proving to be a problem to get replacements for that. And these are redstone boards, right?
Mhm.
How do you replace a blade system like that that's not being designed anymore?
Right.
Like,
With these tightly integrated like HGX style, they have to have I think NVIDIA said this to me word for word. A robot puts these things together. You can't service them yourself. Sure. I mean, I get it, but that's impossible. If I have to take an 8-way board out of service for servicing, that's already troublesome. But for a warranty concern, like who knows? As soon as it becomes non-profitable to run the magic machine that pick and places the eight $60,000 GPUs because they want to place the new $60,000 GPU. Yeah, I mean, all of it gets complicated. And the vendors, it's typically you'd say, well, Lenovo's going to have a warehouse full of something, but they don't anymore. Lenovo's not in any better position than a lot of other companies in the face of Meta or Microsoft or whoever is trying to buy up all this capacity. NVIDIA itself, right? Their new rack is going to eat up how much of their GPU capacity. Just dealing with all these factors that I don't even know how to predict. We start talking about strategies, and I've been thinking about a lot of the same things you guys are talking about. And my in-game nihilism just comes down to I don't even know if that's real. Like the best idea I can come up with feels like it's so fraught by all of these different competing economic factors, environmental factors, like all this kind of stuff that we're talking about. I don't even know how to go out that far and believably say to, my own local, let alone a, federal funding agency, I can definitely deliver that computer for sure. Right. It's for sure we can get all those parts and have that thing on the floor. We'll have that up on a timeline. Like, who knows? One small thing, to the points of many of the things you said, your one small thing can just stop that cluster dead. And the businesses and our own funding sources are just not equipped mentally or physically, as they would say, to deal with the realities of, well, we just couldn't get the NICs. Like, well, fine, man, I'll take the computer and or the HCAs, let's say, I'll take the computer, plug it into Ethernet, and use it as HTC nodes in the short term. That's better than nothing. I'm like, yeah, but I can't ship it to you without the InfiniBand. You ordered them, can't put them in later. So now what? Like, I don't know. I don't know.
Well, I think you two have kind of hit a lot of the good summary points here, right? We have funding that's expecting the world to operate one model. We have availability from manufacturing that is unpredictable. And you have us, the customers and vendors in between those 2 points, all trying to figure out how to function. And I don't think there is a recipe. It doesn't seem like there's a recipe right now that handles any of it well from end to end. But we are at the top of the hour. I do very much enjoy all the contributions you guys brought into this, because I think that hit home on a lot of my concerns. Dory, is there anything we missed that we want to quickly touch on before we wrap up?
No, I don't think so. Thank you all for your contributions. It was a great conversation.
Yeah. So with that, we will wrap this one up. And again, appreciate everybody's participation.